This video is brought to you by mywayteaching.com.
Next is enthalpies for different types of reactions. In that, the first one is standard enthalpy of combustion. Okay, so what is standard enthalpy of combustion? Do you have any idea about standard enthalpy of combustion? See, the standard enthalpy of combustion, we denote this by the symbol delta C. Okay, so standard enthalpy of combustion is defined as the enthalpy change per mole of a substance. Okay, enthalpy change per mole of a substance when it undergoes combustion and all the reactants and products being in their standard states at the specified temperature. Okay, so this is standard enthalpy of combustion. It is defined as the change enthalpy change when there is a enthalpy change takes place per mole of a substance when it undergoes combustion and all the reactants and products being in their standard state at this specified. So all the reactant products are in the standard states at the specified temperature. Okay, next, consider the problem. The combustion of 1 mole of benzene takes place at 298 Kelvin and at 1 atmosphere. So after the combustion, carbon dioxide and water are produced and 3267 kilojoule of heat is liberated. Okay, then calculate the standard enthalpy of formation. Okay, so delta F uh, of benzene, that is standard enthalpies of formation of carbon dioxide and water, minus 393.5 kilojoule per mole and minus 285.83 kilojoule per mole respectively. Okay, so I will solve the problem here. So note down the solution. The formation reaction of benzene, the formation reaction of benzene, that is given by 6C, that is we call this as a graphite. Okay, plus 3H2, which gives rise to C6H6. Okay, the enthalpy of combustion of 1 mole of benzene is the enthalpy of combustion of 1 mole of benzene is C6H6 plus 15 divided by 2 plus this will be gas is equal to minus 3267 kilojoule per mole. Okay, so this is, note down this as equation 2. Next, the enthalpy of formation. Now you consider the enthalpy of formation of 1 mole of carbon dioxide. Okay, see, this one is graphite plus oxygen. This gives, okay, that is minus 393.5. This consider equation 3. So the enthalpy of formation of 1 mole of this is 1 mole of carbon dioxide. Now the enthalpy of formation of 1 mole of water. The enthalpy of formation of 1 mole of water, that is to hydrogen, and it is in gas, which gives half into oxygen. This gives water in liquid form, and then the standard enthalpy of formation is equal to minus 285.83 kilojoule per mole. Okay, this is consider this as equation 4. Next, multiplying equation 3 by 6 and equation 4 by 3. Multiply equation 3 by 6 and equation 4 by 3. So 6c, this is graphite plus minus 2361 kilojoule per mole, minus 2361 per mole. Okay, plus 3 by 2 oxygen gram is equal to minus 857.49 kilojoule per mole. Okay, so summing the above two equations, now this is one equation, this is two equations, so summing about two equations, 6c graphite plus 3h2 plus 15 by 2 oxygen, this gives 6CO2 plus 3H2O. Then for this delta F minus 3218.49 kilojoule per mole. Okay, so reversing the equation 2, here where is the equation 2? This is equation, wait, this is equation 1 and this is equation 2. Now and so you are reversing the equation. Okay, now after that what you have to do, okay, I think you copied this one. I will write here only. Reversing equation 2. So here equation 2 is there. I will reverse this equation. How I will write the equation now? 6 CO2 plus 3H2O. Okay, you are getting C6H6 plus 15 by 2 oxygen. Okay, and its delta F will be H standard, it will be minus is there. So if you are reversing it, you are getting plus sign only 3267 kilojoule per mole. This as equation 4. Sorry, this as equation 6. This as equation 6. And adding equation 5 and 6. Now you are going to add equation 5 and 6. Now adding equation 5 and 6, you know 6 and you know 5 also. So 6 is C graphite plus 3H2, you are getting C6H6. Okay, that is delta FH is equal to 48.51 kilojoule per mole. Okay, so this is the problem. Next is, what do you mean by enthalpy of atomization? Okay, it is the enthalpy of atomization means it is the enthalpy change on breaking 1 mole of bonds completely to obtain atoms in the gas phase. Consider the example of atomization of hydrogen. Consider example, okay, that is atomization of hydrogen. So that is consider dihydrogen, okay, which gives this G means gaseous state, and that is your standard enthalpy of atomization is equal to 435.0 kilojoule per mole. Okay, you can see that H atoms are formed by break. See, H atoms are formed by breaking HH bonds in dihydrogen. H bonds are formed by breaking HH bonds. They are breaking HH bonds, breaking HH bonds in dihydrogen. In dihydrogen. Okay, so the enthalpy change in this process is known as enthalpy of atomization. In this process, whatever the enthalpy is changes, that is known as enthalpy of atomization. So now you just consider this one definition. It is the enthalpy change on breaking 1 mole of bonds completely. Here HH bond is breaking, so completely to obtain atoms in the gas phase. Okay, so this is about enthalpy of atomization. Next is bond enthalpy. So what do you mean by bond enthalpy? And I will explain you. By bond enthalpy, chemical reactions involve the breaking and making of chemical bonds. Okay, where breaking also there and making of chemical bonds, everything. So that is chemical reaction. Energy is required to break a bond and energy is released when a bond is formed. So here what is happening, this is enthalpy. So bond enthalpy means while making a bonds also energy will be released, while breaking a bond also energy will be released. Okay, so this is a bond enthalpy. and its symbol is delta bond. So this is its symbol, that is bond enthalpy. Okay.